Let us look at question number 46 now, students. The magnitude of electron gain enthalpy of chlorine is 3.7 electron volt per atom. The energy released in kilocalories when 3.55 gram of chlorine atoms are completely converted into Cl minus ion in gaseous state is X. We have to comment on the value of 10x to the nearest integer. Okay, students, the magnitude of electron gain enthalpy is given to us. So it is 3.7 electron volt per atom. So students, this can be converted into kilocalorie per mole. So this shall be equal to 3.7 into 23 kilocalorie per mole. Okay, so we can multiply this energy with the actual number of moles which are undergoing electron gain. So if we talk about the moles of chlorine atom, students, we have 3.55 grams. So it means that the moles of chlorine atoms are equal to 0.1. So if we talk about the total energy, students, so the above number has to be multiplied by 0.1. So 3.7 into 23 into 0.1. This is equal to x. So if you solve for the value of x, students, it comes out to be approximately equal to 8.51 kilocalorie. And since we have to report the value of 10x, students, it has to be reported as 85. Students, the answer to question number 46 has to be reported as 85. Let us look at the next question now. Question number 47. A mixture of 0.106 gram of Na2CO3, 1 gram of CaCl2, 4 gram of NaOH and 0.84 gram of NaHO3 is dissolved in water. The volume of HCl of 10 to the power minus 2 molar concentration required for the complete neutralization is x liters. We have to comment on the value of 5x. Okay. So students, we can first find out the number of moles. So 0.106 gram of Na2CO3. So if we talk about the moles, students, it is going to be 10 to the power minus 3 moles, or it is going to be 1 millimole. Okay. If we talk about CaCl2, students, it is not going to react with HCl. It is a neutral salt. Okay, so this does not play any role. If we talk about NaOH, I have 4 gram of NaOH. So it means that there are 0.1 mole, or there are 100 millimoles. If I talk about 0.84 gram of NaHCO3, so this is equal to 0.01 mole. So this can be converted to 10 millimoles. So students, if I talk about the milliequivalents now, the Na2CO3, it has an N factor equal to 2. So the other species have N factor equal to 1 only. So if I talk about the total MEQ of base, this is equal to 2 plus 100 plus 10, which is equal to 112. And this 112 shall be equal to the MEQs of the acid required. So this is 10 to the power minus 2 into the V. So V is in ml in this case. Okay. So we can see that the value of V in ml is 11200. It must mean that the value of X is equal to 11.2 liters. Okay. Since we have to report the value of 5x, students, the value of 5x will come out to be 56. So for question number 47, we have to mark the answer as 56, students. Let us look at the next question now. Question number 48. 1 mole of helium is isothermally and irreversibly expanded at 27 degrees C from 100 atmosphere to 1 atmosphere. The difference in the magnitude of work done when the expansion is carried out in a single step only and in 2 steps, the intermediate pressure being 50 atmosphere, is x joules. We have to comment on the value of x by 100 to the nearest integer. Students, what is happening in this question is the irreversible expansion of helium is carried out in 2 ways. In the first way, the pressure is directly decreased to 1 atmosphere. It is carried out in a single step only. If I talk about the second way, in the second way, the intermediate pressure used is 50 atmosphere. Okay. So we can talk about the value of work done, students. The value of work done is given by minus P external into delta V. So this can be written as minus P external into V2 minus V1. Okay. Now students, this V2 and V1 can be simplified. So this can be written as minus P external into nRT by P2 minus nRT by P1. Okay. Since the external pressure is not mentioned, students, we can assume that the external pressure is equal to the final pressure which is attained by the system. Okay, so this is equal to minus of 1, the nRT can be taken common, into 1 upon 1 minus 1 by 100. So students, this comes out to be equal to nRT into 1 minus 1 by 100. There will be a minus sign as well. So this is the work done in the first process when the expansion is carried out in a single step. We can use this result, students. This result can be used for the second path as well. So in the second path, students, the pressure is first made from 100 to 50, and then this 50 is changed into 1. Okay, so there will be two work, students. We can call that as W1 and W2. Okay, so W1 will be given by minus of 50 nRT into 1 by 50 minus 1 by 100, whereas W2 can be written as minus of 1 into nRT into 1 by 1 minus 1 by 50. So the difference between these works and the magnitude, we'll call it as mod of delta W. Okay, so this shall be equal to nRT, we can take common, into 1 minus 1 by 100 minus of, so this can be simplified to 1 minus 1 by 2 if we include this 50 inside. So 1 minus 1 by 2 is equal to half. So minus half minus, this can be simplified to 49 by 50. Students, this will be simplified to give us nRT into 49 by 100. So if we put the value of nRT in this, students, we're going to have the magnitude of delta W as 49 by 100 into 1 into 8.3 into 300. So this shall be equal to 1220.1. Okay, so this is equal to x, students. So since we have to report the value of x by 100, so it has to be reported as 12. Let's look at the next question now, students. Question number 49. Consider a lattice of A plus B minus in which all the B minus ions are at CCP and A plus ions are at all the octahedral voids. The radius of A plus is 100 picometers and that of B minus is 200 picometers. The packing fraction of the above given AB lattice is x pi by 9. We have to comment on the value of x, students. Okay, so we've been given a lattice A plus B minus, which is similar to the NaCl type structure, students. Okay, so there will be 4 cations and then there will be 4 anions, students. So the volume of these cations and anions can be written as 4 into 4 by 3 into pi into 100 cube plus 200 cube. So students, this is the volume of all these spheres which are present inside the lattice. Okay, so this has to be divided by the total volume. Total volume is A cube, let's say. So A shall be equal to 2 times the radius of A plus and B minus, since B minus are forming the CCP lattice and the A plus are present at the octahedral voids. Okay, so the value of A shall be equal to 2 into 300, which is equal to 600 picometers. So we can just put the value of A cube in this case, students, to give us the packing fraction eta. Okay, so A cube is equal to 600 cube. So we can just simplify 16 pi by 3 into 100 cube plus 200 cube divided by 600 cube. A factor of 10 to the power 6 will be cancelled out, students. So this is going to give us 16 pi by 3 into 1 plus 8 divided by 216. Okay, so this on simplification, students, give us a value equal to 2 pi by 9. Okay, so the value of x, students, comes out to be equal to 0.2. So the value of x has to be reported as 0.2. Let us look at the last question for this paper, students. X gram of a non-electrolytic compound having molar mass equal to 100 gram per mole is dissolved in 2 liter of 0.05 molar NaCl aqueous solution. The osmotic pressure is found to be 4.92 atmosphere at 27 degrees C. We have to comment on the value of x. So students, we know that for the calculation of osmotic pressure, all the ions have to be considered and the effective concentration has to be used. Okay, so we have pi is equal to C effective into R into T. Okay, so we can just find out the value of C effective, students. So pi is 4.92. C effective we have to find out. R is 0.082 as mentioned to us in the question. And the value of temperature is 300 Kelvin. Okay, so this can be simplified to give us the value of C effective equal to 0.2 molar, students. Okay. Now out of the 0.2 molar students, this 0.05 molar NaCl, it contributes to 0.1 molar. Okay. It means that the concentration of non-electrolytic compound is also equal to 0.1 molar, students. Okay. So since we are dealing with 2 liters of solution, it means that the moles shall be equal to 0.2. Okay. And since the molar mass is 100 gram per mole, students, so the total weight or the total grams shall be equal to 20. Okay. So the grams of the non-electrolytic compound added is equal to 20. And students, we have to report the value of X as 20, and the answer to question number 50 is 20. So this is it for today, guys. I hope the solutions were clear to you. Thank you.